Assalamu alaikum. In this lecture, we are going to talk about the short transmission line, which is actually three phase. In the last lecture, we have solved the question related to the single phase short transmission line. But in this lecture, we are going to talk about the theory of three phase short transmission line, as well as we will be solving some question related to the three phase short transmission line. From the figure, we can see that the sending end as well as the receiving end, the load as well as source, both are connected in Y. So if they are connected in Y, we can easily represent it by a single line diagram, which is representing a single phase. So here is an example of short transmission line. We have a three phase transmission line that delivers 5000 kilowatt power to the load at line to line voltage of 22 kilovolt. So if it is not mentioned here that it is line to neutral voltage, in any of the question, if it is not mentioned that what sort of voltage is given, you have to consider it as line to line. But if it is line to neutral, it will be mentioned here that this voltage is line to neutral. So I am considering this 22 kilovolt as line to line voltage, and the power is being delivered at 0.8 power factor lagging. Resistance and reactance of each of the conductor is given, which is 4 and 6 ohms respectively. We have to find the sending end voltage and percentage regulation as well as transmission efficiency. Starting from the sending end voltage, the formula will be Vs is equal to Vr plus Iz. From the question, we know that Z will be equal to 4 plus 6J. Vr is equal to 22 kilovolt, but this is line to line value, so we have to convert it into line to neutral value, which will be equal to 12700 volt. This is line to neutral voltage. This formula is derived from the single line diagram of three phase short transmission line. So therefore all the quantities, this Vs as well as this Vr, these two values will be line to neutral value. So you have to use line to neutral value of Vr in this equation. So now we know the value of receiving end voltage, that is line to neutral. We know the value of impedance. For I value, we have to use the formula for power, the real power that is being delivered at the receiving end. And we know that in case of three phase system, the PR value will be equal to 3 VR IR cos theta or cos phi. And in order to calculate IR, it will be equal to PR over 3 VR cos theta. PR value is 5000 K, 3 into 12.7 K into 0.8, and you will get the value that is equal to 164, and from cos theta you will get the angle which is lagging, minus 36.8 ampere. For this you will have theta is equal to cos inverse 0.8 and minus here because the power factor is lagging. This is due to lagging power factor. So this is your receiving end current. So you will use this here. The voltage value for Vs will be equal to 13815.2 plus 393.6 J. And you have to remember that this is line to neutral voltage. So if you have to find the line to line voltage, you have to multiply it with under root 3. So this is the value of voltage, and if you have to calculate the magnitude for the sending end voltage, that will be equal to 13815.2 square plus 393.6 square, and it will be equal to 13820.8 volt. This is line to neutral. For line to line value, you will multiply it with under root 3, and it will be 23.94 kilovolt. So this is your sending end voltage in line to line quantity. Now the second part of the question is to calculate the percentage regulation. The formula for the percentage regulation was, voltage regulation is Vs minus Vr over Vr into 100. We know the value of Vs, which is 13820.8. The value of Vr is 12700 volt, line to neutral. Similarly, in the denominator, the Vr value is same. So by putting the values in this formula, we are getting the percentage voltage regulation value, which is equal to 8.825%. So the voltage difference between the sending end and the receiving end is 8.825%. So there is a voltage drop of 8 to 8.825% in the line. In the third part, we have to calculate the transmission efficiency. And the transmission efficiency, we know the formula is power delivered over power source into 100. Power source is equal to 3I square R plus P D, which is the delivered power. Now in this case, in order to calculate the sending end power, you have to use 3I square R, because it is a three-phase system. Then you have to use 3I square R, so the line losses are 3I square R, and you will add the delivered power with the line losses, you will get the sending end power. As the delivered power is 5000 K, here the delivered power will be 5000 K. 3 into what is the current value? Current value is 164 square into the resistance, which is equal to 4. So after solving this equation, you will get the value for the transmission efficiency, that will be equal to 93.94%. So about 7% of the power is being lost in the short transmission line, that is presented in this equation. Now in this example, we are going to calculate the distance at which we can deliver the power of 15,000 kilowatt, means the load that has to be attached with the line is 15,000 kilowatt at power factor of 0.8 lagging. We have to build a three-phase transmission line, and the conductor that has to be used has a resistance of 1 ohm per kilometer. The voltage at the receiving end should have the value 132 kilovolt, and the losses in the transmission line can we have a maximum value of 5%. So we have to decide or estimate that what should be the distance of the transmission line if all these parameters are to be fulfilled. So first we have to find a formula that has resistance value in it, because the distance is directly related to resistance. And we know that there is one formula which has resistance in it, which is the losses formula. So 3I square R. So if we know this resistance value, we can easily calculate the distance of the line. So this is actually the resistance of the transmission line, the total resistance of the transmission line. So if we know this resistance value, we can calculate the distance over which the transmission line has to be built. And this I square R formula is used in line losses, and we know that the maximum losses in the line should be less than 5%. It means that these losses should be equal to 5% of 15,000 kilowatt, which is equal to 750, right? 750 kilowatt, and this R will be on this side of equality, and 3I square. Now in order to calculate this current, we know that this is the load power, and I value is equal to P delivered over under root 3 V cos theta. Cos theta is 0.8. Line to line voltage is 132 K, because here we are using under root 3, it means this is line to line voltage, and under root 3 value, and the delivered power is 15,000 kilowatt. So the current value is 82 ampere, and we will use this current value here, and you will get the value of resistance is equal to 37.18 ohm. And we know that resistance per kilometer is 1 ohm of the conductor that we have to use. So length of the line will be equal to R over R per kilometer, means resistance over total resistance of the line. This is the total resistance of the line, and this is the resistance of the conductor per kilometer. So total resistance is 37.18 divided by 1 is equal to 37.18 kilometer. So this should be the length of the transmission line if you have to deliver the load of 15,000 kilovolt, and the maximum losses in the line should not exceed 5%. Thank you.